Here's your Precal 9.2.3 lecture. We're going to do 9-123, 9-124, and 9-125. It might end up being a two-part video. We'll see how it goes. So it says, in today's lesson, you will continue several observations from the work you completed earlier in this chapter by investigating properties of transformations. As you work with these linear transformations, note that each point can be treated as a vector or column matrix. So it says let M equal this transformation vector that we have here, and let P, this can be a column matrix. So it says graph the image of the square with these vertices after a transformation by M. So what that means is I have to multiply this thing by M, and then this one by M, and each one of them separately by M, which I did right here. And so I set it up. These are just each of the four little ordered pairs, the little vectors that they gave me. And I'm multiplying. So I hope that you remember how to multiply. You go -3 times 0 plus -1 times 0 is 0. If you need help with multiplying, please just email me and let me know, and I'll send you a video on that. But basically, this is what I got when I multiplied all those four. And I like to draw stuff, so I drew the original 4 ordered pairs, and then I drew what I got after the transformation, just so I could see. And I was a little bit surprised that it started out with a square, and then it gave me a parallelogram. So it looks like it got stretched 3 to the right, but only 1 up. So and the x's got stretched by 3, but the y's only got stretched by 1. So anyway, what else did it want? It says, let's read what it says. Okay, graph the image of the square with these vertices after the transformation. Do this by writing each point and then calculating M times P. So this right here is the image of the square after the transformation. The parallelogram is the image of the square after the transformation. I just drew the square in there because, well, I was curious. Okay, and then letter B says, graph the image of the square with these vertices after a transformation by M. So it didn't ask me to graph the square, but I can't help it. I like to see what stuff looks like. So I actually I just made my lines closer together, but that's the 2 by 2 square. And then I took all the ordered pairs, the ordered pairs that they gave me, and I multiplied each one of them by the same, it's the same transformation matrix. And I just got all the numbers, and you know how you multiply. You just go 3 times 2 is 6, plus -2 times 1 is -2. 6 plus -2 is 4. 2 times 1 is 2, plus 2 times 1 is 2. 2 plus 2 is 4. Like, that's how you do it, in case you didn't know. So I did A and B. I noticed that for A and for B, I started out with squares. This was a 1 by 1 square and a 2 by 2 square, but I started out with squares and I ended up with parallelograms. Very interesting. You were supposed to be like doing this on your own and kind of discovering it, and you can go ahead and try these on your own, and then you can stop the video and try them, and then start the video up again if you want. Here's letter C. So letter C says, describe in geometric terms the image of this square. So now they've given me another square, -5, like all these 4 points are another square. in relationship to the image of the square from part A, check your description by graphing the image. So let's see, did I do it? Yes. So I actually did it. There's my transformation matrix. It's the same darn one we've been using the whole time, but I used the new ordered pairs they gave me, and I just multiplied, and I got my answers here, and then I got another parallelogram. I keep getting a parallelogram. Every time I do this, there's A, there's B, this one was for C. I keep starting out with squares and getting parallelograms. So you're supposed to notice that. Yeah, it says, describe in geometric terms the image of the square. The image of this square. So the image is actually this big parallelogram. In relationship to the image of the square in part A. So the image is what you get after you have done the matrix multiplication. Well, I'm supposed to compare these two. So I guess what I would say geometrically is that they both appear to be parallelograms. And they even appear to be like, I don't know, parallel, like they're going the same way. So what does your answer book say? Your answer book said, it's a parallelogram with sides parallel to those of the image of part A, but 10 times, oh yeah, it's larger, right? That, I mean, you might have noticed that. It's 10 times as large. This one's 10 times as large as this one, like if you measured. Okay, so what else does it ask us? Without computing, sketch the image of the polygon formed by joining the midpoints of the square given in part B. The square given in part B, so that's this square. That is, sketch the image of this point. These points that they give right here, these are the midpoints of that square. Okay, and I actually drew the whole darn thing because I like to do stuff like that. Where did I do that? This would be the 2 by 2 square, and then the midpoints would be halfway. These midpoints are the ordered pairs that they gave us right here. Okay, and then it says sketch the image of the points. Well, they want me to just do the same darn thing I've been doing. Use this transformation matrix on all 4 of the points. These points right here are just these ordered pairs of this square that's formed by the midpoints of the 2 by 2 square. And so when I do that, I get the image. And the image, surprise, surprise, it's another parallelogram. So then it asks me, oh, check by computing. I guess I already did check it by computing it. So that's 9-23. And now we're on 9-24, or 9-124. I think I'm going to make another video for 9-124. So we'll look for part 2.